welcome to all of you. So, we are towards the closing of this course. So, the last but one lecture is other scheduling techniques. Okay, so now let us start with bar chart. So, bar chart now and then I have discussed here and there, but we have not given a proper introduction on to what is this bar chart and what are the other varieties as well. So, bar chart, the name has come because of the shape of the bar. The shape of the activities are shown as a bar, which is like a rectangular shape, and hence the name has come as bar. And the other name is Gantt chart because of the person who introduced this bar chart is Henry L. Gantt. That is the other reason why we call this as a bar chart. It is the most frequently used tool in construction, and because of the simplicity, ease of preparation and easy understandable format, it is very widely used. Even today, many construction firms are very happy in showing a bar chart representation. Okay. Now, let us take this example. Okay. So, here if you see the x axis primarily shows the timeline. So, these are all the duration in weeks, okay, and the y axis primarily this is duration in weeks, okay, and the y axis shows the list of activities. For example, site preparation, it starts from 0, it takes till 3 weeks to finish, okay. After the site preparation is over, footings starts and it take another 4 weeks to finish, okay. So, like this the bar chart representation goes on, okay, and then foundation, temporary electric service can start in parallel. After the site preparation we have water and sewer tap, then after foundation we have soil treatment, after then we have framing, so then masonry wall. So, this is primarily a structure built as an architectural structure built for the construction, okay. Now, in this example the drawback here is it is not used as a proper document for in case of disputes, okay. Only the CPM schedules or PDM are used, or they are considered as an efficient document in case of disputes and so on, because no relationship between the activities are shown here, okay. And the other problem is sometimes you also, when you are updating on maybe some activities have slipped or extended and so on, it is very difficult for somebody to update on the activities unless you know the predecessors and successors relationships, okay, because network as such will not help you to do that, because there is no relationship shown between the activities. Okay. Now, this x axis I have told, y axis also I have told, it is a list of activities, x axis shows a timeline, and the length of the bar represents the duration of all the activities. Okay. That is the main significance of the bar chart. So, it is a visual or a graphic 2D representation, it has only two axes, x and y axis of a project activities, and the sequence on a time scale bar with no links generally shown between the activities. There are other varieties which shows, but the conventional bar chart will not show any relationship between the activities. Okay. Now, activities representation, generally it is a continuous bar, that is what we have seen, but bar charts can also show non-continuous activities, what we call it as an activity splits. Okay. If you see here footings, it actually starts on 7, then at the time of 4th to 5th week, primarily in that week there is a gap, okay, which implies no work on footings happens, and then the work resumes in the next week onwards. Okay. So, you can show with a blank space, so which is like this. This notation is also possible, otherwise I can also show like this. This notation on bar chart is also possible, and the other way to represent the activity splits are the necking of bars, which implies I am going to make an activity like this. In the no show period, it is a very slender bar, and then we have another rectangle piece. Okay. That is the way we represent the activity splits in a network, okay, in the bar chart representation. Then next is milestone chart. You know what is a milestone, we have introduced in the first week itself. So, milestones are events which does not consume any duration nor any resources. Milestones are significant events which just gives you an information that something critical has to be completed or started on a particular date and so on. So, that is an indication on milestone. And bar charts can also represent milestones and what we call it as a milestone chart. So, this example you remember very well. This was a development of a computational laboratory, and there we talked about milestone planning and so on. Okay. So, primarily when the agenda is to set up the laboratory for January 2020 teaching session, then everything from the all activities regarding the computer setting up laboratory has to be completed before December end. Okay. That is the plans actually. This is broken down into 4 quarters. Okay. Now, if you look at this, so primarily if you go from the last, so software procurement, software installation, and then training has to be done, then only you can start the lab sessions. Okay. Training for the tutors, staff, faculty, whoever you want on important softwares are required. Now, software procurement, I have marked a milestone here. This talks about the class oriented software procurement. When we discussed on this problem, we discussed there were 2 things, 2 classifications. One is primarily for large number of users for class teaching, and other one is few users who use those software only for research purposes. Okay. So, now for the class teaching, so there were few software and this procurement has to be finished somewhere in the first week of December. Installation has to be over in the second primarily in the third week of December, that is the indication I have given. Last week primarily we can plan for training so that the entire lab can start by functioning by Jan. So, there are some milestones and these milestones can be used in the bar charts also. Okay. Now, coming to next, hierarchical bar chart. So, this example you are familiar with is a hypothetical example. The representation of the same example on a bar chart I have given here, but general representation on a bar chart is the activities has to be represented or arranged based on the order of yearly start. So, which implies the C has to be coming here and then we have to have BD. But there is another purpose of putting this bar chart. I primarily wanted to show the hierarchical, so I have kept it like this. Okay, here I am just wanting to show that there are some hierarchical bars for activity A, which is like this, and for activity D. Okay. So, this D is like an aggregation of several activities, and A, which is taking 6 days duration, is an aggregation of several activities put together. There may be several sub activities, relationships, different durations and so on. So, bar charts can also show multiple hierarchical next level layers of representations as well. Okay. Now, next is a fenced bar chart. The main drawback in bar chart we have already told, they fail in showing up the relationship between the activities. Okay. So, now this is a fenced bar chart. So, fenced bar chart just uses straight lines. So, as I have shown here in red color, so from A to B there is a red line, okay, which is seen here, and from for activity D I have again taken an A here, and for to show the C, because there is a float value, so there is a dash and then I am again using a C here. So, that is primarily visible here. Okay. Now, this is primarily the fenced bar chart. Now, let us talk about the linked bar chart. In linked bar charts, what happens is you primarily use arrow marks to show the relationship. So, in a way it is easy to understand rather than the fenced cases. Okay. In linked bar charts, you will see there is an arrow mark from A to B. This shows A and B are dependent, and then I have a straight line here, and then again from A to D and from C to D I still have. Now, here you may have a confusion. The arrow mark from here, is it from A or from B or from both, that you do not know. So, there is a procedure called cascading of networks. Okay. So, primarily what happens is you can rearrange the starts of activities in such a way that it just coincides and forms a shape like a cascade form. So, you can flow the activities like this from both the ends and then it starts merging up just like I have shown here. Now, A gives information to B and there is one more arrow. So, this A also gives information to D and C to D is shown here. Okay. This is primarily called linked bar charts. Now, in primarily in your MS project there is a bar chart view. MS project always represents CPM or PDM network. This is a slab concreting work in hostel. okay, but there is a bar chart or Gantt chart view also. I think people who worked in scheduling techniques know well about this. You can also do resource leveling, resource loading, you can also show cost control on projects, everything you can do, and there is a Gantt view on the whole MS project which is like this. Now this Gantt view, if you see, it's more or less looks like a linked bar chart only, okay. So for example, so this is primarily the aggregated activity, or we call it as a hammock activity. So the part 2 of concreting, then I have part 3 of concreting, okay. So in the part 2 of concreting, column reinforcement, shuttering, concreting, de-shuttering, these are all the resources I need for all these activities. This is only to show the bar chart representations, and the software also I am introducing now then and there in parallel, okay. So MS project predominantly we use in it's very eligible, it's good for what is it called, CPM, PDM and or your bar chart views, okay. Now let us move on to time scale diagram. So I have a small example. Time scale diagram is very simple. The representations of a network schedule. So primarily it is a CPM schedule. Representing a CPM schedule on a time scale is primarily what we call it as a time scale network diagram. Okay, in a way we call it as a AOA representation on an time view, okay, because only on activity on arrows you represent the activities on the arrows. So it's just combining like bar chart and AOA views onto the time scales, okay. So this is a bar chart which you obviously know, okay. Sorry, here also mistake, C has to come here. Okay, now this is a AOA representation. So I have activity A and C are in parallel, okay, they starts in parallel. This is activity AOA representation, and after activity A, B starts, and after A and C, D starts. With the help of a dummy you are showing that logic representations. Now what happens in time scale diagram? This is a time scale diagram, the same relationship I have shown, 0, 5 and this is 10 and this is exactly 11 here, okay. Now if you want, you can arrange all the critical activities on the bottom and the non-critical activities on the top, or you can rearrange it in your own form, okay. Now activity A is shown here, okay. So which is like this, this implies A takes from 0 till this is till 6, okay. Now if you see here, C is starting till here, it is less than 5 still here, so this takes a 4-day duration, and B takes a 2-day duration which is shown here, and after A and C is also shown with the dotted lines I am having here, 2 links are coming in. So this is activity D, and this is an activity D relationship and is shown on a time scale view like this, okay. So this is all about on a time scale diagram, and purpose of using, so only few people use this time scale diagrams because bar chart is very convenient for people with the linked bar charts, okay. Now the next technique, we are just moving on. So if you look at the history also, let us see, first bar charts came in existence, and then your network schedules on AOA first came, then AON. So after then little later only Pert, PDM all came in existence, okay. Pert is the expansion for Pert is program evaluation and review technique. Pert was developed mainly to assist in uncertainties in duration. In CPM schedules, if you see, the duration is always deterministic. What do I mean by that is, the activity duration for any activity, duration which consumed by any activity is always given in single number, deterministic number, and there is no uncertainty in the duration on CPM networks and all. In Pert, what happens is it allows uncertainty. So primarily the uncertainty is covered in 3 forms, okay. 3 time estimates are given. One is optimistic time, then most likely, and the pessimistic time, and because of this uncertainty, this Pert is also used for doing probabilistic estimation on critical paths, subcritical paths, or project completion time. It can also help you to judge or estimate on the probability completion on any activity and so on. So now let us see optimistic time. So it is the shortest possible time for completing an activity if everything proceeds as planned without any problem. Okay. So, if everything proceeds as planned without any problem, and here the activity is performed under ideal conditions, okay, no breakdowns, no delays, no waiting for anything, engineers come, laborers come, everything is starting in time. So, such a short time for completing an activity, what we call it as an optimistic time. Okay. Most likely time, it is a time for completing an activity under normal conditions. So, in this case the conditions are not ideal, minor mishaps may happen here and there. For example, laborers always come 10 minutes late, that happens on almost on all the days of the execution. So, like this all normal scenarios generally happen, okay, waiting time, this, that, and the time duration for all those waiting, all it happens in the same way. The next is pessimistic time. It is a maximum time required to complete an activity under abnormal or extremely adverse conditions in which everything goes wrong. Let us assume the laborers were not even available, they couldn't even come to the site, it was heavy rain, this, that. So, something happened only on the particular day and it got too much of delayed. So, it is primarily the maximum time which has taken, it will not have occurred earlier days in the execution. Okay. But here this estimate does not include natural catastrophes or artificial catastrophes like fire and natural issues like earthquakes, floods, etc. It is not that pessimistic nature. Okay. So, what happens when you are having a duration estimate in 3 times, primarily the optimistic, most likely, and pessimistic? What do? The activity duration in Pert you generally convert into a one time value, and then you still go on in executing the calculations just like how you did in CPM. Okay. So, the activity duration in Pert is given by TE equal to TO plus 4 TM plus TP by 6. So, the most likely time it takes the maximum number of occurrences. Okay. So, you are taking 6 times I estimate, one time on optimistic, one time on pessimistic because it rarely happens, and 4 times on the most likely and divided by 6. There is a statistic background for all this. Anyway, I am not covering all those, but only giving you the formula now. Okay. And I am not also going to talk about the project finish probabilities and so on. Now, this is a simple example I have taken. There are 6 activities in this example. So, excavation, construct foundation, erect building structure, set equipment, install MEP and roofing, and complete the finishes. Okay. So, the 3 time estimates for all the activities are given here as TO, TM and TP, and I have also calculated the TE. Okay. TE I have calculated with the formula TO plus 4 TM plus TP by 6. So, which implies for a excavation 12 plus 4 into 14 plus 16 by 6. So, I got this as 14, 7 plus 4 into 10 plus 13 by 6, this is 10, 15 plus 4 into 18 plus 21 by 6, this is 18, and IPAs for all these activities are also given. Okay. Now, if you look at textbooks earlier to 1990s, 2000 even, you will find most predominantly PERT networks are always shown on AOA, okay, activity on arrow networks. But after then researchers said you can use any form of the notations, either AOA or AON. So, I have shown it in AON network. Okay. So, as I told you, the 3 time estimates primarily you are going to convert into one time estimate, the TE values, expected time for completing an activity, and if you are working on AOA you will still calculate early event times, late event times, slack, and then you will find the duration. If you are doing it on AON, then you will do all the float calculations just like your early start, early finish, late start, late finish of activities, and total float, free float, just like how you did for AON analysis. Okay. So, just to recollect your memory, so I am going to work it out. So, this is a AON network. So, A is the starting activity, after A I have to do B, and after B I have to do my C and my D, then after C and D is my activity E, then my activity F. Durations are all dumped. Okay. C is 18, D is 29.5, this is 9, 7 I have written. So, now this is forward pass I am going to do. So, this is 0, 0 plus 14 is 14. So, this is 14, 14 plus 10 is 24 here. So, this is now 24, this is also 24. Okay. So, now if you add, so this becomes 0.5, 13, 1, 53.5, Okay, now here it is 12:1:42. Okay, now back. So E is early start of activity E is maximum of early finish of these two activities. So this is 53.5. 53.5 plus 9 becomes 62.5. So now this is 62.5 and then this is 69.5. So now working backward pass, which is the late starts and late finishes. So this is 69.5. Okay, 69.5 minus 7 is 62.5. So this is 62.5. 62.5 minus 9 is 53.5. So this is 53.5 and this is also 53.5. 53.5 minus 18 is so this is 0.5, this is 5, 4 minus 1 is 3, and what about here? So this becomes 0. So 13 minus 9 is 4, this is 24. Okay. Now the minimum of these two values is 24, so I have to go with 24. 24 minus 10 is 14, so this is also 14. 14 minus 14 is 0. Okay. Now if I want to do the total float calculations, I am going to change my pen color now. Okay. So 0 minus 0 is 0. Okay. 14 minus 14 is 0. 24 minus 24 is 0 and 53.5 minus 53.5 is 0. 62.5 minus 62.5 is 0. Now this is 0.5, 1, 11.5 is my total float. That the critical path is activity A, then I have activity B, then I have activity D, and then I have activity E, and then I have activity F. Okay. So the same way so primarily the Pert you are converting into deterministic times on expected. So T is expected time of completing an activity, and then you have to go out with the same procedure like how you did for CPM calculations. Okay. So now we have discussed so far on non-network schedules. Bar chart comes in that category. The various I would say the other updates or improvements in bar chart also we have seen. The next we saw Pert. So primarily it's close to CPM. So CPM and Pert we have seen what is the difference. So CPM, Pert, PDM also we have discussed in detail. Now let us move on into advancements in these techniques. Okay. So CPM, the other one is called GPM. Okay. GPM, the abbreviation is graphical path method. Okay. These techniques I may not be showing you duration calculations and scheduling and so on, they are not that powerful techniques, but I am just giving you an awareness that there are so many techniques available in scheduling. Okay. And you should know what are all available. So GPM is a network technique again that offers the simplest possible schedule in the shortest possible time. Okay. So the abbreviation is graphical path method. Now what happens here? So this GPM it has come after you are primarily on the CPM network only, and what happens is when you are showing your calculations on total floats, you are calculating on critical path and so on, and once the project is progressed, okay, and during the as execution period, okay, half of the project has progressed and so on, and if you want to know what has happened in the as built portion, then it is very difficult for somebody to look at the updates and do analysis on the as built portion. Okay. The GPM is a method which helps you to analyze the as built portion and helps you to identify the float places, drifts and so on. Okay. Where are the buffers available, what has happened. So it helps you to analyze where any mistake has gone and so on. Okay. That is the primary advantage of using a GPM. The ability to determine total floats and the critical path for the as built portion of a schedule, primarily the left of the data date. Okay. When you are working on project controls, you will know what is a data date. Data date, other name is called status date. It is a date on which you take updates on the project progress. Okay. That is primarily determined by the CPM. Now CPM is widely used. Now these are the steps I would say on the building up the GPM. So CPM you know is widely used as a project management tool for planning and scheduling, and the basics to CPM is primarily you have to draw a network and from where you calculate the project completion time, total floats, critical path, etc. Primarily you do network schedules and also you do network analysis on a AON network. Okay. Now, once the actual dates are introduced in the CPM network, like maybe you plan 6 days it takes, but what happens is the first date may be on 1st of July and the 6th date may be on 7th of July. When the actual dates are implemented and the as built drawing is really generated, we start losing out the information on the data date, which implies a previous data date like total floats and where are all what happened, the flaws in the where are the delays happened and so on. We generally we do not take a notice of, okay, we miss all those, and the critical path can no longer be calculated. So, for those instances GPM is very widely used. Okay. Now, if you see there are certain terminologies we have specifically for GPM. Number one is called drift. This is not the complete list, there are so many terminologies like this. Number one is drift, the amount of shift to earlier planned dates while not forcing an earlier project start, is primarily called as a drift. The next is float, the amount of shift to later planned dates without causing an overrun in a project completion. So, in a way it is like a total float sort of setup in your CPM. We call in GPM, the name given in GPM is float. The next is drift buffer, the amount of shift to earlier planned dates without forcing any of its predecessors to earlier dates. Okay. So, primarily what happens is there is an endpoint software for operating on GPM. So, when I am shifting an activity, it tells me how much I am shifting, and because of my shifting pre data date, okay, is there any predecessor activities or should be deviated, or it gives me a caution as to the predecessor activities are not have to be also preponed and so on. Okay. So, accordingly you have to see how much is a drift, how much was the buffer these activities have consumed, we can still explore. Next is buffer, the amount of shift from planned dates without delaying any of its successors from their respective planned dates. In a way it is like your free float we have in CPM terminologies. Then we also have other terminologies like offset, embed, forensic floats and so on. Okay, now let us move on, because my purpose is only to introduce these techniques to you. The next is Gert. So, Gert similar like GPM, it is an advancement to Pert. Okay. In Pert you know why we introduced Pert. Pert has come into existence only to allow uncertainties in durations. Okay. So, Gert has come developed by Pritzker. It has developed as means to advancements in Pert. Okay. So, in Gert also we can allow deterministic duration as well as probabilistic duration estimates, just like your Pert. So, Gert is same as Pert in that sense, but Gert is different from Pert in two ways. One is it allows loops. Okay. If you take any of the network schedules like your CPM, PDM, Pert, etc., they does not allow loop, even your GPM, but Gert can allow loop, okay, because of the probabilistic branching and so on. And Gert also allows probabilistic treatment of network logic and branches. In the sense it can also have two links, and one of the link can be operational and the other one will operate only under certain situations or circumstances. So, it can allow either one link to operate, both the links to operate. So, it allows branching of, that is what we call it as a branching of a network. With the example you will understand later. Then Gert networks include directed branches, okay, which implies arcs, edges and transmittances, and logical nodes also, which we call vertices. So, two parameters are linked with the branch, one is a probability time and the other one is the time taken, time required for the branch to take. Okay. Now, there are certain terminologies in Gert. Okay. One is called input terminology and the other one is output terminology. And how do you draw the network? Because I told you the network itself is very probabilistic, and so the network itself should be guided as to whether this arrow should work out or this arrow should work out. In CPM, if you draw two arrows, both the arrows will be operational at every point of time. Okay. In Gert, it need not happen. So, logical relationships on the input. Now, let us see the symbols and then we will see an example. So, when I am drawing a straight line with a triangle, it is called exclusive R, and only one of the branches leading into this node can be realized at a given time. So, only one branch leading from the node will be realized here. Okay. The next is inclusive R. The realization, so primarily it is only a triangle shape. The realization of any branch leading into the node causes the node to be realized. Okay. So, whatever comes in, it just does its operations. Okay. Next is AND. The node will be realized only if all the branches leading into the node are realized. I may have 2-3 links entering into this setup. So, what happens is when all the links are having are ready for start, then only this branch will work, otherwise it will not work. So, this is the input. Now, let us see the output symbol. So, primarily I am having two symbols here. Okay. One is like a D shape and the other one is a triangle shape. So, D shape stands for deterministic and the triangle stands for probabilistic. Okay. Now, here the D1, all the branches emanating from the node are taken if the node is realized. Okay. So, all branches will be operational here. Then probabilistic, exactly one branch emanating from the node is taken if the node is realized. Whenever there is an enough input coming in, only one branch will be operational. Okay. Last 3 cases we have seen only on the input. So, I am talking about arrows coming into the network. Okay. In this case on the output, when you have the symbol in the end, I am talking about arrows starting from the particular network. Okay. Accordingly, now I have several combinations here. You will see there are so many combinations here. Okay. So, this stands for input and this stands for output in all the cases. This stands for input and this stands for output. Okay. If you see here, so you cannot use this separately, you have to use combinations only, because you need to know what is the input criteria for taking up the network and what is the output criteria. Okay. If you see here, the first one is primarily exclusive R and deterministic, the next one is exclusive R and probabilistic, and the third one is exclusive R and deterministic, then the next one is inclusive R and probabilistic, then next is and deterministic and probabilistic. Okay. Now, let us take an example. I would say this is a gas station construction which happens in a hill station. Okay. I would say where landslides are more in number. This network was drawn, this example was drawn with DSM, but primarily what I wanted to show here is there are 3 uncertainties which are encountered, which are seen in the entire network. Okay. Whenever you have an uncertainty only, we want to draw a Gert network. Okay. So, we have taken these 3 as uncertainties here. Number 1 is on PCC, plain cement concrete. Number 2 on bar bending and reinforcement. Number 3 on concreting and compaction. Okay. So, it is primarily excavation or breaking of rocks and then disposal of rocks, then PCC, primarily pouring of concrete, then bar bending or reinforcement, cover blocks, then shuttering, batching, concreting, compaction and curing. Okay. What happens with the hill station with a lot of landslides? Every time you may have to redo the work again if the landslides have occurred. Maybe you have done excavation, landslides have happened, then you may have to re-clear the site for the next level of excavation. Okay. So, this is a simple network which we have taken it up, and the representation on Gert looks like this. Okay. Now, these are the symbols which I have used earlier, combination symbols. Every time you may have to use this combination symbols. Okay. Only in the start or end you may use a single symbol. Okay. Now, let me write everything so that it is easy for us to understand. So, this is exclusive R and deterministic. Okay. This is exclusive R and probabilistic. This is inclusive R deterministic. So, this is inclusive R probabilistic, this is and deterministic, this is and probabilistic. Okay. So, I am starting, and what shape is this? This is unprobabilistic. This has come because of the link I have in here. Okay. So, now let us start with the activity. Do not see the symbol will be operational only when the backlink works. Okay. So, I have two arrows coming in, one is excavation and site clearing, and the other one is rock breaking and site clearing. Okay. So, I have two modes, either I may have to clear up my earth by excavation, or I may have to do rock clearing also. So, there is an uncertainty coming in. Okay. So, and implies all the links coming earlier has to be considered, and probabilistic is, so either one of them will be operational. Okay. Either I may have to do excavation, or I may have to do the rock breaking and site clearing, because I have told probabilistic end I may have only one link operational. So, suppose I am taking excavation, okay, there is no rock, I am only doing excavation there. Okay. So, again what happens, as and when this link works, this will start, again I may have either one of the links only, either I may have to do no PCC, or I may have to do PCC work. Okay. So, now what happens here is, there may be a problem with the pouring of concrete itself, because I told uncertainty happens at that place itself. So, I may have to do PCC, or I may also avoid my PCC. Okay. Because of what? There may be a landslide which has happened. So, when the landslide happens, I may not be able to do PCC, I may have to re-clear due to landslide, and again I may have to repeat the process. Okay. If the PCC happens, in the sense if there is no landslide, no uncertainty has happened, then I am going to go to the second step in my operations, which is the plain cement concrete work. Okay. Same thing, instead of excavation I had a rocks available, then I may have to do rock breaking, and when the rock breaking happens, again there may be a landslide which may happen. So, once either I may do no PCC, or I may have to do PCC and then do the land clearing process. Okay, that is what. So, if there is a land clearing, then I may have to come here and do the land clearing and again repeat the steps accordingly. If there is no land clearing, if there is no landslides, then I may do with the PCC work. Okay. So, whether I have taken excavation work or my rock breaking work, I could do my PCC if there is no uncertainty that has happened. Now, there is again an inclusive or probabilistic link given here. Okay. Now, either reinforcement work can happen or reinforcement failure can happen. Okay. Maybe because of my quality of reinforcement or something, reinforcement failures are more common there, or maybe I have tried to put in the reinforcement in the excavated portions and landslide has collapsed everything. Some uncertainties can happen with the reinforcement also. In the earlier slide itself I have shown you 3 places with the study on previous projects, we have identified that uncertainties can happen on these 3 instances. So, reinforcement work can happen, or as I told you only one link may work, okay, or reinforcement failures can happen. Okay. Now, when the reinforcement failures happen, then rework has to be happen. So, again the reinforcement work has to be passed on, or if that is because of the poor quality of reinforcements. Okay. Or if the landslide has happened and collapsed my reinforcement, then the re-clearing of the landslide has to happen, again excavation and all these work has to happen and proceed. Okay. Then once the reinforcement is done, then we go on to shuttering work. Okay. This is primarily the and deterministic. For shuttering, I need the concrete line re-clearing and also the repair of the mixture or setting up mixture. So, I need all the things to be ready, and then only I have to go with my laying of concrete lines. Okay. Now, with the concrete lines, I may again have a failure. Concrete may happen because of my may happen. Okay. When there is a rain or a snow, I know what precautions to take. Sometimes concreting may not also happen with the hindrances. Okay. So, concreting happens and concreting has not happened. So, this is concreting without hindrance and concreting has failed because of the rain or snow. Okay. Now what happens here is, now this has gone to the target accomplished stage. Okay. Now if there is a hindrance due to local people or something, then target not accomplished, and then this network has to go in loops. When you give the probability value as to what is the probability that PCC may fail or your reinforcement may fail, according to the probabilistic values you dump in onto the network, then what happens is accordingly the durations can be calculated. But still no far has worked on duration calculations on this, but it can help you to draw the network on probabilistic branches and roots. So this was developed by Pritzker. Okay. Now moving on into, so primarily if you have seen, we have covered CPM and PDM very much in the first few classes. Now previous to PDM or CPM, we had the bar charts that we have discussed right now. Then we had Pert, which we missed. Advancements to CPM also we have seen GPM. Advancements to Pert is the Gert, that also we have seen. The next is your PDM relationships, and advancements to PDM we can say it is the BDM or your RDM. Okay. Relationship diagramming method and B-line diagramming method are generally called as an advancements. B lines are to represent multiple relationships, and when you want to have a resource dependency shown on the network, then RDM can play a picture. Okay, these are all called advancements. Now, in the BDM network itself, if you want to represent more information, then some researchers have developed a network called continuous and point to point relationship. Okay. This was developed by Hajdu, Michaelis Hajdu, and what does he say is, I am having an activity, this is a legend with which you can understand. The legend has name of the activity and duration. So, this says activity A duration is 5, activity B duration is 10, activity D duration is 20, activity F duration is 20. Okay. And there are different types of relationships given. Point to point relation, it says primarily the first point, second point and the time gap. In your BDM you always had N1 and N2, and if you want to have N1, N2 with a time gap, then you can mark this as F, S and O. Primarily the finish, the first segment, the second segment, and then the time lead or lag. Okay. So, FSO here there was no finish to start, and there was no time lag here, no time lag here. So, after this activity is done only you have to start, but here after 1 day of activity you can give information to F and there is no wait. So, it is primarily the start, and then I have a 0. So, there is no lag here. Okay. Now, here there are also written in terms of duration and distance. Okay. So, the XM it talks about work gap and the X day it talks about time gaps. So, now when you have F0 on the arrows, it means it is a point to point relationship, and when you are having an X days or XM, it talks about time gap or the work gap, which implies continuously between two activities I am having a relationships here. When you are talking about repetitive activities in, for example, what happens is, you may have, let us assume I am doing excavation with one stretch, second unit, third unit and so on, and suppose if you want to maintain a continuous interval between all these segments, then I may have to maintain an it may be a time gap or it may be a distance gap. Okay. 1 meter ahead I should not keep all my equipments, and there should be a minimum clearance of 1 meter, then you can write 1 meter there, it shows a work gap. Otherwise, 1 day later the activities should progress, then throughout excavation and the second activity, then you can maintain the X day as a distance buffer. Okay. So, this technique is very helpful in showing the repetitive activities also, because what these researchers say is, in reality you may have activities with continuous and non-continuous put together. So, you need a representation which shows a non-continuous segment also along with the continuous or repetitive portion of activities. Okay. For that case this is very useful. Okay. Next is LSM. LSM is linear scheduling method. In the regular class, I explained you on line of balance method. Line of balance, you know, primarily you have to draw two bars in order to show the primarily the start of the segment and finish of the segment. There is nothing called early and late, okay, which shows start of unit 1, finish of unit 1. So, it shows as a rectangular bar and the entire progress till the last unit is seen here. Okay. In LSM, what happens is it shows, so primarily this is a network, it shows only one horizontal line, okay, and with an inclination to the horizontal. So, primarily I have taken 3 activities A, B and C, okay, and this is the duration of the activities, and this shows a units 1, 2, 3, 4 and so on. Okay. So, I am having an activity, primarily I am having an rectangle here, this shows the time taken with which the first unit is done. Okay. So, the first unit, when I am drawing a line, it says I am finishing it at 3 days, the second unit I am finishing it at 6 days, third unit I am finishing it at 9 days and so on. So, 0 to 3, okay, 3 to 6, that is how you have to represent or interpret your LSM schedules. Okay. Now, for here there is a distance buffer also. In the earlier LOB also we showed the buffer by means of a start buffer or end buffer. Same case here also we have to show the buffers in LSM. Now, what happens is there are software which are very specific only for repetitive activities. Okay. We are just moving on into that, but there can be an non-repetitive portions also in a repetitive stretch of an activity completions. Okay. This is not a new technique, what we call as a time chainage diagram. This is a very old technique which came in soon as your LOB was formulated. Okay. There are so many terminologies along with this, then only the CPM form of a network call came in existence. So, these all techniques have come even earlier to CPM schedules. Okay. So, time chainage diagram, it just talks about time plus chainage. Now, we are into repetitive activities. So, I have duration as my stretch, and I should also know where are these activities going to be done in the whole chainage. Okay. I am having an 200 days of my duration, and when you are saying excavation, it takes for the throughout stretch, but you should know on day 60 to day 80 this excavation is happening on which stretch. Okay, and where is the other activities happening at that particular point of time. So, primarily the chainage is the whole segment or distance, I would say, along with you are representing your time. This is widely used for all repetitive projects like your road projects, bridges, tunnels and so on, and it is easy to know the order of activities, locational happening of activities and etc. Okay. Broadly, the researcher has classified 4 types of activity. One is a compact. Compact is generally shown with the inclined line. Okay. These examples I have taken with the help of earthwork example only. Okay. Maybe curb laying or fencing. Okay. Extended lines, I may have parallel inclined lines here. This is primarily to show concrete paving. Maybe there is a duration there and it is like a completely happening an activity. Then extensive activities are shown as blocks. For example, earthwork. Okay, earthwork can be done throughout the stretch of your highway construction, okay, which you may have to show it as an complete block till the chainage is completed. Static, primarily show it in vertical columns. In the entire highway segment, I may have bridge maybe in 1 or 2 places only, bridges, junctions or tunnel shafts. So, only in few places I may have the vertical columns coming in and to show the bridge construction, piers, abutments and so on, and with that I am closing my the diagrams. Okay. So, these are the main features in non-continuous representations. Okay. And there is a specific software which helps to show your repetitive projects, okay, what we call it as a Telos. Okay. So, Telos is primarily the time linkage on software. Okay. And here you see this is the same example what we have discussed earlier on highway widening project. So, I am having, so this is the snapshot on Telos. So, I am having a March, okay, April, then May, these are all the weeks. Okay. I am starting on 10th week is somewhere in March, 11th, 12th, 13th, 14th, 15th and so on. So, these are the weeks. okay, and along with the year of representations. Okay. Now, excavation work is starting somewhere in the 12th week of the project, so which is happening in March, okay, and it is finishing in somewhere in close to the 14th week of the project progress, okay, which is supposed to be the end of March, towards the end of March. This is the project progress week and this is your month, the relevant month on which this entire work is going on. Then excavation, embankment, these are all parallel inclined lines which shows your regular activities. Okay. If you see here, compact activities are shown generally by inclined lines, right. So, these are all your compact activities. So, first excavation, then next is embankment, subgrade, granular subbase, wet macadam mix, then I have my DBM, then this is my bituminous concrete mix. Okay. So, all these are shown, the crew connectivity is also shown for the next levels and so on, because I am sharing so many resources between the activities, which during the RDM modes we have discussed this also. Now, let us move on into see the time chainage representations on Telos. This is again a Telos snapshot only on the same project, wherein I have raised a bridge also to continue with my highway construction. Okay. So, these are all girders here. The girders are primarily the extensive activities which are shown like blocks and they occupy the complete chainage, okay, almost most of the chainage. Okay. Suppose if the entire construction is happening on bridge and highways, then you may have to show all these on girders, on extensive activities. Okay. These piles are all static portions which happens only from this particular segment to this particular segment. Here you will have a chainage also, okay, and I have to crop it because I didn't have I couldn't put it fully. Okay. Below this at the end I may have the chainage also which shows 0 kilometers, 2 kilometers, 2.7 kilometers, this may be 3.2 kilometers, all these can happen and you will know. So, this from this particular distance to this particular distance I am doing my foundation. Foundation is happening from this time to this time, the second foundation is happening from this time to this time and it is happening in the month of April 3rd to 4th week. So, all these you can interpret on seeing the figure only. Okay. So, it is still a visualization diagram and also an analysis tool on repetitive construction projects, that is all about Telos. Okay. So, now we are just wrapping up from the beginning. So, first non-network schedules we have seen, network schedule CPM and PDM we have seen earlier. Now, we have discussed Pert, GPM, Gert and so on, and then we moved on into repetitive construction projects. LOB we have discussed enough in detail in the regular class. Now, I have introduced to you LSM and time chainage charts, and this Telos can help you to to represent these networks also. Okay. MS project or Primavera is very relevant for all your earlier schedules like your CPM, PDM, bar charts and so on, and then Telos is very good for LSM. It will not show LOB scales, it only uses LSM and time chainage charts. Okay. So, in a way repetitive projects can be shown on this Telos. The next is types of activities. We are just moving on into types of activities to show where we are and what all we have discussed so far. So, independent activity, dependent activity we seen, we know what is it. So, your CPM, bar charts, whatever you have discussed so far will surely take care of independent and dependent activities. The next is semi-independent. Semi-independent is you need not wait till the end of an finish to start conventional relationship. If you are ready to send any pass on any information or you are ready to start your work any time in the midway of your previous predecessor, then you can use a relationship called semi-independence activities. Okay, your PDM can really represent this semi-independent activities. This you can use CPM, you can use Pert or you can use bar charts. So, all these are helpful for that. I am not talking about repetitive activities here. Okay. Next is interdependent activity. DSM is a powerful tool for representing interdependent activities. We have seen that in very much detail. The next is multiple two-way information linkages or B lines, and BDM is a very powerful method for introducing, and if you want to mix and use on repetitions and BDM and so on, then so BDM is primarily like point to point, okay, and if you want to have continuous relationships on distance, time and so on, then you may have to use what Professor Ajdu has used on continuous and point to point relationships. So, all these you know what tools we can use and how to do the scheduling with all these methods. Okay. But one thing you should understand, these are all primarily comes under the classification called natural overlaps, wherein the information can pass on easily at that time and you are scheduling only with that knowledge. Okay. Suppose if you want to force and activities to release information ahead of something or behind something, and then you wanted to schedule and project, then you may have to do forced overlap. Okay. Forced overlap I am not going to cover in this particular course. Okay, and interested researchers, you may have to go through research articles only on forced overlap. So, all these are on natural overlaps and we have seen all these techniques right now. Okay. So, everything has been covered, some in detail, some at least I gave you an idea as to what is it. Okay. So, starting from bar charts, you have all the other varieties like milestone chart, fenced bar chart, linked bar chart, hierarchical bar chart and so on. Then time scale diagram, network schedules, CPM, Pert, PDM, repetitive projects. So, these are the groups with which under they fall in. Okay. LOB, LSM or time chain edge diagrams. Other techniques like GPM, Gert, which are like extensions to CPM or Pert, and then BDM and RDM are like extensions to PDM, and then we discussed on DSM also. So, now let us look at the software, because I said I will also introduce to you the software issues. So, MS Project Primavera you can use very much for showing on bar charts or for network schedules and so on. Even for repetitive projects you can still use, only thing is it is not a specialized software. So, special software only for repetitive projects you can still use Telos. Okay. Then next is NetPoint. NetPoint is primarily recommended for GPM only. And then we have B-liner. B-liner it allows you to do only on contiguous activity executions. Okay, that is for BDM method. Then we have Qualica, PSM 32, Adapt, then DSM at IITM. So, these are the software we have for DSM analysis. Okay. Qualica and PSM 32 you can use till partitioning method. Qualica I have not much used. Adapt is a special software which was developed by construction group, and you can easily do till tearing and repartitioning. Adapt does not allow you to do proper iteration modeling. It just focuses on a black box approach on iteration modeling. Okay. And DSM at IITM is primarily a MATLAB based version. So, you do not have a GUI. So, it is difficult for users to primarily use 0 space, 1 space and type all the inputs. That is the one drawback we have there, but these all can help you to do the analysis. Now, whatever is the technique I have shown on the left hand side, you can still use XLVB or MATLAB in order to go ahead. Okay, you can also help prompt your MS project with XLVBA analysis, and then you can still work on. Okay. VBA is Visual Basic Applications for in Excel mode. So, these are all the software we have. Okay. Now, especially for simulation, I said simulation is like it can cover any aspect in construction. Okay. Simulation software specifically for construction, there are few. One is Cyclone and Stroboscope Educational. This was developed by one particular group of researchers. We also have Symphony and we also have Analogic. Okay. Symphony and Analogic are paid software, and the first two are free for education academic institutions. Okay. So, these are all on the glimpse on the software. Now, so far I have we have discussed on few techniques which are primarily for scheduling aspects, and we have also seen what all the software can help. Okay. But I am not going to cover more details on software because it is only a course on scheduling aspects only. Okay. Now, there are some planning methods which can also help or assist in scheduling. Okay. Under that category there are few methods. One is lean construction or last planner, The next one is flow diagram. Under the flow diagram, there are so many techniques like data flow diagram, IDFO and so on, a flow process diagram, etc., etc. And one method in that is work study. Then we have 4D BIM. Okay, BIM is building information in modeling, and the 3D is primarily the visualization part, and when you add time with the 3D, we call it as a scheduling. It can support schedules, okay, which we call it as a 4D BIM. So, with this I am just closing off. Acknowledgements. So, time to acknowledge so many references I have taken from journal papers, books. Okay, the list is too big. So, thanks to all of them. Then there were TA students who helped in this course. There were few research scholars. Thank all the MTech project students, because all these data examples have come mostly from the MTech project works. Okay, I have guided so far 60 MTech students, and these data all have come from those project works only. Thank you. I hope you would have enjoyed.